All right, folks, this is your error analysis for Learn Check number 7. So we're working on solving square root equations. All right, number 1, we just need to solve for the values of x. So I have the square root of 19 minus 4x, and that is set equal to the square root of 7 plus 2x. The first thing we need to do is get our radical isolated, whether that's on the left side or the right side. Remember, isolated means that it's by itself. Now, it just so happens to be that on both the left side and the right side, the radical is by itself. If you're looking at the 19 and the negative 4x and asking if that is like part of the radical or not, well, it is part of the radical because it's underneath the radical sign. But if I had any numbers or variables in front or behind, that would be an issue. Same thing for the other side. If I had something in front or behind, then that radical would not be by itself. Again, you only need one radical by itself on one side in order for this next step to work. So radicals are isolated, so then it's time for us to undo. So these radicals are square roots because there's no index written, so we can assume it's a 2. So again, we're going to square both sides. When the exponent and the index match, they are inverses of each other. So that means we're going to be left with 19 minus 4x is equal to 7 plus 2x. From here, this is pretty simple because we just have x to the first power, x to the first power. We can just solve like normal. I can't simplify the left or the right side, so that means I can go straight into solving. I want to combine my x's together, so inverse here to move this to the other side. And we're going to subtract 7. So that's going to be 12 is equal to 6x, and then divide by 6. So 2 is equal to x. Remember that we always need to check and make sure that this is a true solution, that it's not extraneous. So remember that we're going to plug it back in. So we're going to do this. We're going to have the square root of 19 minus 4 times 2 is equal to the square root of 7 plus 2 times 2. This would be the square root of 19 minus 8, which is the square root of 11. Over here, this would be the square root of 7 plus 4, and the square root of 11, so that works. So this is our answer. All right, number 2, we need to solve for x and identify the extraneous solution, aka which one is fake. So let's go ahead and do that. I'm not going to rewrite this one since we have some space here. Now, this radical is not by itself. It's got this 1 and this negative sign in front of it. Now, I will say that this negative sign kind of bothered some of you all. Y'all didn't know how to handle that one 100%. I'm going to rewrite this. Remember that that negative sign is really a negative 1 that's being multiplied in front of the radical. And maybe if you rewrote it like that, it would have made a little bit more sense. So this 1 in front is a positive 1. Notice that there's a sign in between the 1 and the other 1. There's this negative sign here. That's why I'm able to subtract this 1, because this 1 was being added. It's not being multiplied. So that means I still have a negative sign or a negative 1 in front of this radical. And this would be now 3. Now, some of you all, your negative sign just kind of disappeared from one line of work to the next line of work. You can't just disappear a sign or a number or a variable in math. That's just not how things happen. we got to get rid of this -1. This -1 is being multiplied by that radical because there's no sign in between here. So if these are being multiplied, the inverse is to divide. So the square root of x plus 2 is equal to now -3. This beginning part up here, this is where most of you all had issues if you had an issue. So make sure you understand why that is happening and the difference between this 1 and this negative and how this first one is being added because it's a +1 versus how this negative sign is being, multiplied. All right, so now that our radical is by itself, we are going to square both sides, because again, this is a square root. Index and exponent match, so they go away. X plus 2 is equal to a negative times a negative is a positive, so this would be 9. And then we are going to subtract 2 and subtract 2. So that would mean that x is equal to 7. So we need to solve for x and then identify the extraneous solution. So we need to see if this is true or extraneous. So we're going to check that by substituting it. So 1 minus the square root. Instead of an x, this would be 7 plus 2 is equal to 4. 7, 8, 9, so square root of 9. 1 minus square root of 9 is equal to 4. 1 minus the square root of 9 is 3. Oh, interesting. So 1 minus 3, that would be -2 is equal to 4. Yeah, that's not true. So that means this is extraneous. So solve for x and then identify the extraneous solution. So that would mean that 7 is the extraneous solution. Some of you picked no solution, which means that you are trying to identify the true solution. But that's not what the problem asked you to do. The problem asked you to identify the extraneous solution, the fake one. So that's why 7 was still the answer, because you identified the extraneous solution, not that there was no solution based off of the true one. All right, number 3. Now, number 3, it wanted you to identify the sum of the possible solutions. So we need to figure out what the value for x or x plural x's is, and then add them together because it says the sum. So let's go ahead and get with this. So we need the square root of -18 plus 9x is equal to x. Again, we're checking to see if our radical is by itself. It is, so we can square both sides. The radical and the exponent go away because they match. X squared is just x squared. Ooh, now we should hopefully notice that we have an x squared here. That means that this is a quadratic. And the only way to solve a quadratic is to either factor or quadratic formula, or you could use completing the square, but that's not something that we have focused on a lot this semester, or really at all until the end. So really, I would go with factoring. So if we're going to factor, or even if we did quadratic formula, we would need to put this in standard form. I like it when my a is positive. So personally, I'm going to go ahead and add 18 and subtract 9x. 0 is equal to, I'm going to put these in order, x squared minus 9x plus 18. My A is 1, my B is -9, and our C is 18. I'm going to notice that my A is equal to 1, which means that when I factor this, I can use a shortcut. X method, 1 times 18 is 18, and -9 at the bottom. So coming up with our side numbers, we could do like 1 and 18, but that wouldn't be -9. Yeah, I would do 6 and 3, because 6, 7, 8, 9. This has to be a positive up top and a negative at the bottom. So if you think about this, we should make both of these negative, because a negative times a negative is still a positive. But when I combine two negative numbers together, it's going to still be a negative when they're combined, like added together, still two negatives. So these are our side numbers. Now, normally, we would take these side numbers and we would replace B with it and then do grouping and all that. However, if your A is equal to 1, you are allowed to set up your parentheses, and then your side numbers go right inside your parentheses, -6 and -3. And ta-da, there's no GCF, so this is factored form. Again, this only works if your A is equal to 1. So now to go from factors to solutions, remember that we need to set equal to 0. So x minus 6 is equal to 0 and x minus 3 is equal to 0. So that means we're going to add 6 and we get x is equal to 6. We're going to add 3 and x is equal to 3. All right, so we're almost done, but we do need to check and make sure that both of these are good solutions. We got to check twice. So we're going to do the square root of -18 plus 9 times 6. And that should be equal to 6. So let's check this one. So 9 times 6 is 54. And 54 minus 18 is going to be 36. So the square root of 36 is still equal to 6. And yeah, that makes sense because literally the square root of 36 is 6. So that works. All right, let's check 3. So the square root of 18 plus 9 times 3. And that should be equal to 3. All right, 9 times 3 is 27. And we're going to do 27 minus 18. So we get 9. So the square root of 9 is equal to 3. And yeah, 3 is equal to 3. That works. So if these are both good solutions, I need to make sure I answer my question. So I'm going to find the sum of them. And that last step there, that is what a lot of us missed. So 6 plus 3 is equal to 9. And 9 is our final answer. All right, last but not least. So again, we're going to solve for x and then identify the extraneous solution. So we don't want the true solution, we want the fake solution. We want the extraneous one. So let's go and get this set up. So the square root of 8 minus 2x plus 4 is equal to x. Now when I go to get the radical by itself, notice that on the left side it's got this plus 4 here, so I'm going to get rid of that by subtracting 4. So we have the square root of 8 minus 2x is equal to x minus 4. My radical is by itself and it's a square root, so I'm going to do the inverse by squaring it. Once I do that, I should have 8 minus 2x is equal to, now right here, got to be careful. Some of us want to distribute this exponent. We are not allowed to do that because x minus 4 squared is x minus 4 times x minus 4. And that means that we need to do a quick box method to multiply this together. So we would get x squared minus 4x minus 4x, and then negative times a negative is a positive, so 16. Once we combine like terms, we're going to end up with x squared minus 8x plus 16, and that's equal to 8 minus 2x. All right, we got to notice this quadratic, which means we need to get into standard form because we're going to need to factor or use quadratic formula. So I'm going to go ahead and subtract 8 and add 2x. Notice that there are some terms that we can combine. That's why I have those organized. So x squared, this is going to be negative 6x and plus 8. All right, so again, there is no GCF, but we do see our A, which is 1, our B, which is negative 6, and our C, which is 8. I am noticing that my A is a 1. So let's go ahead and set up our X method. So we've got 8 and negative 6. I know I'm going to end up using 4 and 2. Again, when these multiply, it's got to be a positive. So either they're positive and positive, or they can be a negative and a negative, which that works because I need them to combine to be a negative 6. So these are our side numbers. And because our A is equal to 1, I don't have to do full grouping. I can jump straight to factored form. Again, there's no GCF, so x parentheses, negative 4, and then negative 2. And again, equal to 0. This is our factored form. I need to get to solutions though, and solutions, we set each of these equal to 0 and solve for x. So I know I'm a little tight on space here. I'm going to do it here off to the side. So like x minus 4 is equal to 0 and x minus 2 is equal to 0. So add 4, we end up with x is equaling to 4. Add 2, so we get x is equal to 2. Now we need to see if both of these are true. Maybe one of them's extraneous, the other one's true, or maybe both are extraneous. And the only way we can do that is by substituting and actually checking. So the square root of 8 minus 2, let's start with 4, and then plus 4 is equal to 4. So 2 spots for x, so 2 places where we substituted 4. All right, so let's do this. 8 minus 2 times 4 is 8, so 8 minus 8 would be 0. And we know that the square root of 0 is just 0, so 4 is definitely equal to 4, so that is a good one. So this is true. All right, let's do 2. So the square root of 8 minus 2 times 2 plus 4 is equal to 2. Again, making sure we plug in 2 for both values of x. All right, 2 times 2, so it's going to be 8 minus 4. So 8 minus 4 is obviously 4. So the square root of 4 plus 4 is equal to 2. This is already not looking good because the square root of 4 is 2. 2 plus 4 is definitely not 2 because that's 6 is equal to 2. No. So this one is the extraneous one. And it asked us for the extraneous one. So that meant our answer was actually 2. Because again, that is the one that is extraneous. It did not ask me to solve for the true solution or just solve in general. It wanted to know what's the extraneous solution. All right, well, hope that helps and good luck retesting.